Elon Musk just made a bold move in the EV war with China. One new engine, and the country that was supposed to win it all is suddenly staring at a future that no longer belongs to them. China is in shock, and for once, that is not an exaggeration. For years, the story was simple. China was going to win the EV race. More factories, cheaper batteries, faster production, lower prices. BYD passed Tesla in total electric vehicle sales. The numbers were on China's side and everyone knew it. So when Tesla unveiled a motor with a carbon fiber sleeve wrapped around the rotor, spinning beyond 20,000 revolutions per minute, accelerating from 0 to 60 in under 2 seconds, the reaction in Beijing was not applause, it was silence. Because Tesla did not just build a faster motor, they moved the entire battlefield. But here is the part worth thinking about. Tesla did not hide it. They opened the patents. Any engineer in Shanghai or Shenzhen can read every page. So why does China still have a problem? Why can you know the recipe and still not cook the dish? And what does this mean for the millions of people about to buy an electric car over the next few years? Those are the questions we are going to dig into. And I promise you, the deeper we go, the stranger the story gets. To understand why this rattled China specifically, you have to understand how China was planning to win. The Chinese strategy was never about building the best motor. It was about building good enough motors at a price nobody else could match. Vertical supply chains, government support, raw materials locked down, factories running at a scale the West could barely imagine. BYD, SAIC, NIO. These are not small startups anymore. They produce millions of cars at costs that make American and European automakers sweat. The plan was to flood the world with affordable electric cars and let price do the rest. And it was working. Then Tesla changed what the competition was even about. Let's start where it matters, the rotor, the spinning part inside the motor that turns electricity into motion. In most electric cars today, that rotor is built from copper and steel alloys. Good materials, decades of use, but with a hard physical limit. Spin them too fast, and centrifugal force rises exponentially. The metal starts to deform. Heat builds, precision drops, efficiency collapses exactly when you need it most. Tesla solved it with something simple to describe and brutally hard to do. They wrapped the rotor in carbon fiber. The same material you see in Formula One cars and spacecraft, with a stiffness-to-weight ratio steel cannot touch. Lighter, stiffer, far better at handling force at high speed. That carbon layer creates a compressive pressure, a preload, that holds the rotor together even as it screams past 20,000 revolutions per minute. The result is power and acceleration that used to live only inside million-dollar hypercars. Tesla put it in a sedan, and here is why China noticed. Because speed was never the point. The point was efficiency. A lighter rotor needs less energy to spin. Same battery, more range. The cooling system works less. The battery lasts longer. Every benefit feeds the next one, a loop that makes the whole car better. China's advantage was building cheaper cars. Tesla just built a fundamentally more efficient one. So why can't China simply copy it? The patents are right there. Now this is the part that genuinely surprised me. Wrapping carbon fiber around a metal rotor sounds easy. In reality, it is one of the hardest manufacturing problems Tesla has ever faced. Carbon fiber and metal expand at different rates when they heat up. Wrap it wrong, and at 20,000 revolutions per minute, that carbon layer can crack, peel, or throw the rotor into a violent imbalance. You can imagine what happens next. To solve it, Tesla built an entirely new robotic system from scratch, run by artificial intelligence, applying the carbon at micrometer-level precision, not millimeter, micrometer, 1,000th of a millimeter. It controls the fiber tension, the temperature, the wrapping speed, the exact angle all at once, then checks the result with laser sensors before a single rotor is approved. Every rotor, individually inspected. That is the trick. The patent shows you the design. It does not give you the machine. It does not give you the AI trained on thousands of failed attempts. It does not give you the years of refinement. And even if you somehow had all of that, you would still need to bake it into a production line running tens of thousands of units a month. Opening the patents was never generosity, it was a message. We have gone so far that even our secrets cannot save you. But let's be honest, because this is not the whole story. Tesla has real problems too. This carbon process is expensive. Each rotor costs far more than a conventional one, which raises an obvious question. Can Tesla ever bring this down to the Model 3 and Model Y, or does it stay locked in the high end forever? And in a global price war, the best technology does not always win. China understands that better than anyone. There is also the part nobody at Tesla wants to dwell on. The company leans heavily on one man. Musk's promises slip. His controversies pile up. Self-driving has been promised for years and still has not arrived the way it was sold. For buyers over 45, the ones with enough experience to be skeptical of hype, trust matters more than a stopwatch number. None of that disappears because the motor is brilliant. So how does China actually respond? This is where it gets interesting. BYD has the scale and the supply chain Tesla can only dream of, building its own batteries, chips, and components. Its costs are lower, and it is pushing hard into Europe, Latin America, and Southeast Asia. But BYD's brand and software still struggle in America, and tariffs keep it largely locked out of the home market Tesla dominates. China can outproduce Tesla. The question now is whether it can out-engineer it, and that is a much harder fight. And here's the thing nobody expected. During the presentation, Musk dropped a line most people missed because they were staring at the acceleration numbers. He hinted this motor could go far beyond cars. Think about electric aviation, where the single biggest barrier has always been a motor that is light enough, yet powerful and reliable enough to fly. Light, powerful, thermally stable, able to run at high RPM for long stretches. That is exactly the wish list. Think about wind turbines, industrial pumps, grid-scale storage. If Tesla mass produces these motors cheaply, it stops being a car company and becomes the engine supplier for an entire clean economy. That is the part that should worry China most. While its automakers race to build a better electric car, Tesla is quietly trying to build the infrastructure underneath the whole next century. Those are two completely different games. But before we crown anyone, remember the lesson history keeps teaching. Betamax was better than VHS, and VHS won. BlackBerry had the better keyboard, and the iPhone erased it. Nokia ruled the phone world, and then vanished. A technical lead does not guarantee a commercial victory. Battery prices are falling fast, which narrows any cost advantage. Government incentives shift. Tariffs and supply chains can be rewritten overnight by a single political decision. So has Elon Musk really ended the EV war? Is China truly in shock? Or is it already in a lab, somewhere building the answer Tesla won't see coming? Honestly, I don't know. And anyone who tells you they know for certain, you should not trust them. What I do know is that the next 3 to 5 years will decide the shape of this industry for decades. The motor is real. The lead is real. Whether it lasts is the one question even Tesla cannot answer yet.